Alright, in this video we're going to introduce voltmeters and ammeters. But first of all we want to have a look at, just introduce the difference between a series circuit and a parallel circuit. So if we have a look at the circuit on the left, and we have an example of two resistors connected in series. So these ones here. This is a series connection. Okay, and what it says here is that in series circuits, all of the current passes through all the components. Okay, so all the current passes through all the components. In this example here, on the other side, we just have these. I just want to focus on those part of the circuit. So those, the 4 ohm and the 12 ohm resistor, they are connected in parallel to each other. And what happens with a parallel connection is that the current will flow through the path of least resistance. So more of the current will flow through the 4 ohm resistor than the 12 ohm resistor. But the thing is, the one thing we have to remember, that I is going to be the same here, still going to be the same after. So even though in this part of the circuit, the current is going to be larger than this part, when they join back up again here, the current is going to be exactly the same as it was before. So I is still the same, and I is still the same, because the current will be the same through the whole circuit overall. If we don't look at the individual bits in these kind of parallel configurations. Okay, so it can be a little bit confusing, but just remember that before and after the parallel section, that the current will be the same. So we're going to speak about ammeters. So ammeters measure current. So ammeters are used to measure current, and the clues in the name, it's like amps. So ammeters measure current. So we need to have all the current flowing through them so they're connected in series with other elements of the circuit. We don't want the ammeter to affect the current, so they are designed with minimal resistance. So we don't want to actually, we just want to measure the current without actually impeding the current at all. Now voltmeters, they measure voltage, okay, or in other words, potential difference. So a voltmeter is connected in parallel with the device across which we are measuring the voltage. So because we want all the current to flow through our device, our component that we're measuring, we design a voltmeter with very high resistance. So like I said before, if most of the current would have flown through this 4 ohm resistor compared to the 12, if we made that 12 ohm, or if we made a voltmeter with, say, like, I don't know, 1,000 ohms or 10,000 ohms or whatever, like a million ohms, then not much current, or if any, is going to go through. The equivalent of no current is going to go through that voltmeter, so we can measure it without actually affecting the voltage across that. Okay. So note that with ammeters and voltmeters, so if you come to doing some practical stuff, the positive terminal must be connected to the positive side of the circuit as shown. So we have the positive here, and then for the ammeter, the positive is there, and the voltmeter, the positive is there. Okay, so that's just for practical tips. Exercise in circuits and meters. I just wanted to have a look at this first one here, because this, I was a bit confused when I saw this diagram for the first time as well. So I just want to kind of go through this one. So essentially what we have is a circuit here. If we just focus on the components of the circuit, we have a battery, and then we have a resistor there. And what this question is asking is, where would you put an ammeter and where would you put a voltmeter? So I'll get a couple of different colors. So let's just say, what color do I want my volts to be? I'll go yellow. Okay, so we have a voltmeter here. So all we had to do was connect it in parallel with our resistor. So we're just trying to measure it across our 4 ohm resistor. So what we could do it is we could put it here and here. And the places that we have in there are M2 and M3. So we could draw our voltmeter there, or we could put our voltmeter in here. Okay, so now if we get a different colour, and I'm going to go with the green this time. It's been a while since I've used green. Actually, I want my pink to, first of all, we want to draw our circuit first, don't we? Draw our circuit again with our resistor. No, that's not very good. We don't want to do that. Let me put in the resistor like that. Probably going to give you a big clue where we're going to put it. So get my green in there. It's not ideal, but we're basically going to have wires coming in here. The ammeter. We need to put it. We can put an ammeter in here, or we can put an ammeter there. Okay. So essentially, we can use either M1 or M4 for those ones as well. So either or. We don't have to use all of them. But you wouldn't use two. You could put your voltmeter across either. It's going to be the same there, or use one or the other ammeters and just use the wire. So that's basically the answer. So for a ammeter, we would say M1, M4. Oops. It's not responding. Now, typical. So M1, M4 is the answer for that one, and up here was just M2 and M3 was the answer for the voltmeter. All right. While we're here, we may as well do the next exercise as well. So a student finds that the current through a resistor is 3.5 amps, while a voltage of 2.5 amps is applied to it. So what is the resistance? So let's just draw our circuit in. Why not? So we have a voltage of 2.5, and we have 3.5 amps going around it. So then the resistance, V over I, which equals 2.5 over 3.5, and that's going to be equal to three significant figures, 0.74 ohms. So what would be the current if the voltage were doubled? Well, we don't really need to do any maths on it really. If we double, or the current, if we double voltage, then we double the current as well. Okay, so we know that. But if we were to work out, if we did want to work it out, you could say I is equal to V over R, which is equal to, the voltage would be 5 volts over 0.714, and that comes out as 7 amps, which is the same as doubling 3.5. Okay, so you can check it. So what voltage must be applied if the current is 1 amp? Okay, so V equals 1 times 0.714, so that's equal to 0.714 volts. So what this is basically saying is that if 1 amp is flowing, the magnitudes of both the resistance and the voltage, it must be equal. Oops. Oh, gee. Magnitudes of voltage and resistance must be equal. And this is probably pretty obvious if you look at I equals V over R. Because I is equal to 1, V and R must be the same. Okay, and now we just have the summary of the equations that we've covered up to this point.